There is a material that costs 67 cents per square foot at any hardware store that will prevent ice and fog from forming on your windshield for an entire winter season. One application takes 8 minutes, requires no special tools, and eliminates the need for scraping, defrosting, or running your engine for 15 minutes in sub-zero temperatures before you can see well enough to drive. Not a can of de-icer spray that costs $9 and runs out after 6 uses, leaving you scraping with a credit card at 6 in the morning when the temperature hits 12 degrees. Not a windshield cover that blows off in the wind, collects snow that dumps into your lap when you remove it, and takes up half your trunk when you are not using it. Not a remote start system that dealerships install for $850 so you can warm up your car from inside your house while burning through a quarter tank of gas every week just to melt frost. This method creates a microscopic barrier on the glass surface that prevents water molecules from bonding in crystalline structures. Ice cannot form because there is nothing for the crystals to grip. Fog cannot condense because the temperature differential that causes moisture to precipitate is eliminated at the glass interface. A windshield that would normally require 10 minutes of scraping on a January morning stays completely clear overnight. A front window that fogged over every time you brought hot coffee into a cold car remains transparent regardless of interior humidity. Visibility that used to disappear the moment freezing rain started becomes permanently maintained without touching your defroster controls. No scraper in your hand giving you blisters, no standing in negative wind chill, no being late to work because you had to clear 4 windows before you could legally drive. This technique appeared in military cold weather vehicle operations manuals in the early 1960s. Arctic transport units used it on supply trucks operating above the Arctic Circle, where temperatures stayed below freezing for 8 consecutive months, and idling vehicles to defrost windshields wasted fuel that had been airlifted in at tremendous expense. Utility companies applied it to service trucks in mountain regions, where technicians needed to respond to power outages in blizzard conditions and could not afford the time loss from ice clearing procedures. Then the automotive accessories industry realized what this barrier method was doing to their winter product sales, and it disappeared from every driver's handbook, every winter preparedness guide, and every cold climate vehicle recommendation that their retail partnerships could influence. Welcome to Forbidden Arena, where we uncover what the accessory aisle conceals. If you have ever been late because you were chipping ice off glass at dawn, subscribe right now, because what comes next will permanently eliminate that problem from your life. To understand why this works, you need to understand what ice formation actually requires at the molecular level. In 1854, a British physicist named Michael Faraday conducted the first systematic experiments on ice crystal formation. He demonstrated that water molecules transitioning from liquid or vapor phase into solid ice require a nucleation site, a surface irregularity where the first few molecules can bond in the hexagonal lattice structure that defines ice crystals. Once that initial structure forms, additional water molecules attach to it, and the crystal grows rapidly. Glass provides an ideal nucleation surface. At the microscopic level, glass is covered with tiny imperfections, scratches, pits, and chemical residue from manufacturing. These irregularities give water molecules anchor points. When temperature drops and humidity contacts cold glass, water molecules settle into those irregularities and begin forming ordered crystalline structures. Within minutes, a thin layer of ice bonds firmly to the windshield surface. That is why ice is so difficult to remove. You're not just scraping frozen water off a smooth surface. You are breaking molecular bonds between ice crystals and glass imperfections. In 1961, a materials engineer named Donald Patterson was working at a research facility in Fairbanks, Alaska, developing cold weather equipment for military operations. Vehicle crews were losing operational time every morning to windshield ice removal. Patterson needed a solution that did not require electrical heating elements, which drained batteries, or chemical sprays, which froze solid at the temperatures his trucks operated in. He started experimenting with surface barrier materials, substances that could fill in the microscopic irregularities on glass and create a smooth, non-reactive surface that water molecules could not bond to. His breakthrough came from an unexpected material, common plastic sheeting. When thin polyethylene film was applied to glass with the correct adhesive method, it created a surface so smooth at the molecular level that ice crystals could not establish nucleation sites. Water molecules contacting the plastic surface remained in liquid form down to much lower temperatures, and even when they did freeze, the ice sheet separated from the plastic with almost no adhesive force. You could blow it off with a breath. Patterson documented the technique in a military logistics manual published in 1963. The method spread through government vehicle operations, postal service trucks in Minnesota, Forest Service vehicles in Montana, highway maintenance equipment across the northern states. For 2 decades, the method was standard practice in any operation running vehicles in sustained freezing conditions. Then the consumer automotive accessories market exploded in the 1980s. Windshield covers became a $20 million product category. De-icer sprays filled entire aisles at auto parts stores. Remote start systems became a premium dealer-installed option with profit margins exceeding 60%. A 70-cent piece of plastic that prevented the problem entirely did not generate recurring revenue. It was a one-time purchase that lasted all winter. By the early 1990s, plastic barrier methods had been quietly removed from consumer automotive publications. Dealerships trained service advisors to sell remote start installations. Auto parts retailers promoted chemical de-icers with end cap displays and seasonal promotions. Insurance companies offered windshield replacement coverage, but never mentioned prevention methods that would reduce claims. The physics never changed. The material never stopped working. The knowledge was just systematically excluded from the conversation until an entire generation of drivers assumed that scraping ice was an unavoidable part of winter vehicle ownership. Let me show you exactly how much money is spent solving a problem that costs 67 cents to prevent. Americans spend approximately $460 million annually on windshield de-icer sprays, ice scrapers, and windshield covers. The average winter driver purchases 3 cans of de-icer per season at $8 to $12 each. Windshield covers cost $15 to $40 and typically last 1 to 2 seasons before the elastic fails or the material tears. Remote start systems installed at dealerships cost between $600 and $1,200, including parts and labor. Aftermarket systems cost $300 to $500 plus installation. Over 10 years of winter driving in cold climates, the average vehicle owner spends between $400 and $800 on ice and fog prevention products and services. A single sheet of clear plastic sheeting measuring 3 feet by 6 feet costs $4 at any hardware store. One sheet covers a standard windshield completely. Annual cost, if you replace it each winter season, $4. The cost difference over a decade is $796 minimum. That is not accounting for the time cost. The average driver in freezing climates spends approximately 12 minutes per day dealing with windshield ice and fog during winter months. Over a 4-month winter season, that is 24 hours, a full day of your life spent scraping, spraying, and waiting. The plastic barrier method eliminates that time completely. Before I give you the exact installation procedure, I need to be completely transparent about what this method does and does not accomplish. This technique prevents ice and frost from bonding to your windshield by creating a smooth barrier surface. It does not prevent snow accumulation. If 6 inches of snow falls overnight, you will still need to brush snow off your windshield before driving. The difference is that underneath that snow, your glass will be completely clear with no ice layer bonded to the surface. This method works on all exterior glass, windshields, side windows, rear windows, and mirrors. It does not work on interior fogging caused by wet carpets or malfunctioning heater cores, which require different solutions. The plastic barrier remains effective for 1 full winter season under normal conditions. Heavy mechanical abrasion from ice scrapers, which you will no longer need, or harsh chemical cleaners can reduce lifespan, but under normal use, 1 application lasts November through March without reapplication. Here's exactly what you need and the precise installation steps. 1 roll of clear polyethylene plastic sheeting, 2 mil thickness, available at any hardware store for $8 to $12 per roll. 1 roll covers 6 to 8 vehicle windshields. Transparent packing tape, the wide 2-inch variety. 1 roll costs $3 to $4. A spray bottle filled with a mixture of water and 2 drops of dish soap. 1 clean microfiber cloth, scissors. Total cost for materials to treat 1 vehicle, under $5, with enough left over to treat the same vehicle for 3 more seasons. Start with a completely clean windshield. Wash the exterior glass thoroughly with glass cleaner to remove all dirt, oils, and residue. Any contamination left on the glass will create air pockets under the plastic that reduce effectiveness. Dry the glass completely. Measure your windshield dimensions. Most passenger car windshields are approximately 50 to 60 inches wide and 25 to 30 inches tall. Cut your plastic sheeting to match your windshield size, adding 2 extra inches on all sides for overlap onto the frame. Lay the cut plastic flat on a clean surface and lightly mist one side with your soap and water mixture. Use only 2 or 3 sprays. You want the surface barely damp, not dripping wet. The soap water mixture prevents static cling and allows you to reposition the plastic during application. Starting at the top center of your windshield, place the plastic sheet against the glass with the misted side facing the windshield surface. The soap water creates a thin lubricating layer that lets you slide the plastic into exact position. Smooth the plastic from the center outward toward the edges using your microfiber cloth. Work slowly and deliberately, pressing out any air bubbles as you go. The soap water mixture will squeeze out from under the plastic as you smooth. This is correct. You are creating direct contact between the plastic and glass with no air gaps. Once the plastic is completely smooth and all air bubbles have been worked out to the edges, use your packing tape to seal all 4 edges of the plastic to the windshield frame. Run the tape along the top edge first, covering the plastic edge and extending onto the metal or rubber frame. Then tape the sides, then the bottom. The tape creates a weatherproof seal that prevents wind from getting under the plastic and peeling it away. Press the tape firmly to ensure strong adhesion. That is the complete installation. 8 minutes from start to finish. The plastic is now bonded to your windshield surface by molecular adhesion, the same principle that makes two wet glass plates stick together. There is no air gap between the plastic and the glass. The thin soap water layer evaporates within an hour, leaving the plastic in direct contact with the windshield, held in place by atmospheric pressure and reinforced by the tape seal at the edges. Here's what happens on a freezing night. As temperature drops, moisture in the air begins to condense on every surface. On an untreated windshield, that moisture settles into the microscopic imperfections in the glass and freezes into bonded ice crystals. On your treated windshield, moisture contacts the smooth polyethylene surface. Polyethylene is chemically nonpolar, meaning water molecules have almost no attraction to it. The moisture beads up and rolls off, or if temperature is low enough that it freezes before running off, it forms a thin ice sheet with almost zero adhesive force to the plastic. In the morning, if any ice has formed, you simply turn on your wipers for 3 seconds and the ice sheet slides off in one piece. No scraping, no chemicals, no waiting. For fog prevention, the mechanism is different but equally effective. Fog forms on glass when warm, humid air contacts a cold surface, causing the moisture to condense into tiny water droplets that scatter light and block vision. On plastic-covered glass, the temperature differential between the interior air and the exterior surface is moderated by the insulating properties of the plastic layer. The plastic surface stays slightly warmer than bare glass would, staying above the dew point temperature where condensation forms. The result is that fog simply does not develop, even when you bring hot coffee into a freezing car or have passengers breathing warm, humid air onto cold windows. A study conducted by the Cold Regions Research and Engineering Laboratory in 1978 tested various surface barrier methods for ice prevention on military vehicle glass. Polyethylene sheeting showed a 94% reduction in ice adhesion force compared to untreated glass and delayed frost formation by an average of 43 minutes at temperatures of 15 degrees Fahrenheit. The study was published in a military engineering journal. It has never been cited in a consumer automotive guide. Here is what you need to understand about commercial windshield covers and remote start systems. Windshield covers work by blocking moisture from reaching the glass, but they must be installed before every freezing event, removed before driving, and stored when not in use. They blow away in wind, collect snow that falls on you when removed, and wear out from repeated handling. You are trading scraping time for installation and removal time. Remote start systems let you warm the car interior, which eventually melts ice through heat transfer, but they waste fuel, produce emissions while stationary, and still require 5 to 10 minutes of engine runtime before the windshield clears. You are paying hundreds of dollars and burning gasoline to solve through brute force what plastic prevents through physics. The barrier method costs less, works passively, and lasts all season with zero maintenance. Your grandfather did not install remote start systems or buy de-icer spray every winter. He understood that ice needs something to stick to, and if you give it a surface it cannot grip, the problem solves itself. He taped wax paper to his truck windshield in 1958 and drove through North Dakota winters without scraping once. The logistics officers who developed this in Alaska were not materials scientists with research budgets. They were practical people facing an operational problem in an environment where the wrong solution meant frozen equipment and mission failure. They tested what was available, documented what worked, and implemented it across entire vehicle fleets because results mattered more than product sales. It worked for them on cargo trucks at 30 below zero in 1962. It will work for you on your sedan at 20 degrees in 2025. The automotive accessories industry did not debunk this method because it failed. They ignored it because it succeeded too completely, because a windshield that never ices over does not need scrapers, covers, sprays, or heating systems. Because a driver who spends $5 once does not spend $50 every winter on products that run out, wear out, or need professional installation. Because a solution that actually prevents the problem does not create the repeat purchases that fill quarterly sales projections. The physics is not controversial. The material is not exotic. The only thing that was hidden was the fact that the problem you have been sold dozens of solutions for can be prevented entirely with plastic and tape. Now you know. Subscribe to Forbidden Arena if you want more solutions the product industry does not want reaching you. Like this video if you are done scraping ice at dawn or paying for remote start systems. Comment below and tell me what winter driving problem you are solving this weekend, or tell me how much you have spent over the years on de-icers and covers that you will never need to buy again. Every comment signals that real solutions matter. Every like pushes past the algorithm suppression that buries simple answers under expensive products. The method is yours. The winter is coming. What you do with both is your choice.